what are the number of forward path which is present in the signal flow graph. That is the first step. Okay, so in a step 1, I am going to finding out the number of forward path. So if you consider the number of forward path, so this the diagram or signal diagram. Okay, so in every branch the arrow mark is given which will represents the signal flow directions from one node to the another node. Okay, so if you take this one, so the first forward path, how many number of forward path is present here is, this is the one path and there is a no other path present with parallel to this one. So we are having the number of forward path equal to 1. Okay, so I am going to draw the forward path 1 to 2, 3, 4, 5 to 6 and up to C of S. So here the transfer function is 1, G1, G2, G3 and G4. Okay, so what is the transfer function of this forward path is? So all the forward path is it is represented as Pk. So it is P1. P1 equal to this. All the transfer functions are connected in series. So we will already tell you the formula. If it is in a parallel, you have to add. If it is in a series, just you have to multiply the transfer functions. Okay, so 1 into G1 into G2, G3 and G4. So you will get G1, G2, G3, G4. Okay, so this is the only one forward path which is present in this signal flow graph. Okay, so no other forward path direction is present here. So it is a very simple loop. Okay, so next we are going to finding out. So we find it out this Pk, then we are going to calculate the del value. Okay, only. So if you calculate the del, we need the formula is 1 minus sum of individual loop plus 2 non-touching loops. Okay, is there is any the individual loop is present, so the loop is nothing but you are having forward and again the feedback is present. So here 1 arrow mark, 2 and 3 arrow marks is getting back to the input directions. Okay, so it is the all the other arrow marks in a input to output, but this arrow marks from the output to the input, so that is called as a feedback. Okay, so we can number of individual loops. So first we have to consider the number of individual loops which is present in this signal flow graph. So one individual loop is this and again coming back to the H2. So if you take that one, you will get G1, G2, G2, G3 and again it is getting back minus H2. Okay, so here G2, G3 minus H2. Okay, and the another individual loop is present here is this one. So from node 4 to 5, 6 again coming back to the node 4, that is the one loop. Okay, so this is the first one and the second one is you draw this one. So from node 4 to 5, 5 to 6 and again which is coming back to the node 4. Okay, so here this is first G3 and this is G4 and while coming back it is a minus H1. Okay, and the another loop is present. So here from the node 2 to 6 in a forward direction again which is coming back to the node 2. So this is a third loop. So any other loop is present? No, only 3 loops are present in this signal flow graph. Okay, so we are going to write the third loop here. Okay, so the third loop is G1, G2, G3, G4 and again which is coming back to the G2. So okay, so from the 2 G1, G2, G3, G4 and the feedback is minus 1. Okay, So there are three. How many number of individual loops is? Number of individual loops are 3. Okay, so we don't miss any other terms because we can lose some marks. So we have to carefully identify the number of individual loops and two non-touching loops. So if you take the transfer function of this loop is, what is the transfer function of this loop? Individual loop is, we can calculate is G2, G3. So we can calculate the individual loop is the transfer function P1, or so you can calculate the transfer function by multiplying G2, G3 into minus H2. So you can represent G2, G3 minus H2, and the transfer function of this loop is G3, G4 into minus H1. So minus of G3, G4 into H1. Okay, so for this loop, the transfer function is the series. So you are multiplying it G1, G2, G3, G4, and where I am minus 1, so it is a minus. Okay, so there are 3 individual loops we are identified, and 2 non-touching loops. 2 non-touching loops. So how many 2 non-touching loops which is present in this signal flow graph is, here this is a one loop, this is second loop and third loop. So we can consider it in any order, but this loop is merged with this one, and these 2 loops are merged with the third loop. So there is no 2 non-touching loops. That is, non-touching means, so the 2 loops, it should not have the same node. Okay, so here we are having the same node 3, 4, 5 will be present in this loop 1, loop 2 and loop 3. Okay, so the same node should not be present. So the 2 loops which will be present at the 2 different nodes and which is not touching each others. So okay, that is the meaning of 2 non-touching loops. And here the number of 2 non-touching loop is no or 0. So there is a no 2 non-touching loops. Okay, so and if there is no 2 non-touching loops, 3 non-touching loops, and the remaining 3 non-touching, 4 non-touching, 5 non-touching, everything is a nil. Okay, so the 0 is there is a nil conditions for the other. So only you are having the individual loops. So we can change this Mason's gain formula for this signal flow graph in the following way. So C of S by R of S equal to 1 by del into summation of P1 del 1, P2 del 2, but here only one forward path is present. So this summation is for only one forward path. So it is P1 into del 1. Okay, if there is P2 del 2, P3 del 3, it will be added up, but here it is having only single forward path. So we are having P1 into del 1, and we have to calculate the del 2. So already P1 is calculated, and del 1. So del 1 is the number of loops which is not touching the that particular forward path. Okay, if there is any forward path, this is a only forward path. All the loops are touching this forward path. So the del 1 value is, it is the del 1 equal to 1, because there is a no loops are not touching that particular forward path. Okay, so next we are going to calculate del. So the del equal to, so you know that 1 minus sum of individual loops plus 2 non-touching loops. There is a no non-touching loop, so it is a 0, 0, and it is so on. Okay, so we can consider only 1 minus sum of individual loops for calculating this del. Okay, so it is equal to 1 minus, so what is the sum of individual loop gains? You have to add it out. So it is nothing but minus G3, sorry, G2, G3, H2 minus G3, G4, H1 minus G1, G2, G3 and G4. Okay, so we can take the minus commonly outside and you will get it is 1 plus G2, G3, H2 plus G3, G4, H1 plus G1, G2, G3 and G4. Okay, so this is the del value we are calculated from the signal flow graph. So now we can use this Mason's gain formula and get the C of S by R of S equation for this particular given signal flow graph. Okay, so here substitute here. So the Mason's gain formula. So from this one C of S, or here I can write it out. So if you write it, so C of S by R of S equal to, from this gain formula, it is 1 by del this value, and P1, what is a P1 value? It is G1, G2, G3, G4. Okay, so you have to write this G1, G2, G3, G4. So G1, G2, G3, G4. Okay, and your del 1 value is 1. Okay, so del 1 value is 1, so it is multiplied with 1 divided by, okay, del value. What is the del value? Del value is this one. Okay, 1 plus G2, G3, H2 plus G3, G4, H1 plus G1, G2, G3 and G4. Okay, so if you see that this is the final transfer function of this signal flow graph which is given in the diagram. Okay, so in the same way, any signal flow graph is given in the questions, so you can easily convert into the number of forward path which is present. You have to identify it correctly. Then after finding the number of forward path, you have to find it out the number of individual loops present in this signal flow graph. So after finding the number of individual loops, you have to get the transfer function for all the individual loops. Then you have to find it out any non-touching loop is present in the signal flow graph. So if there is a two non-touching loop, again you can draw the transfer function by multiplying the transfer function of the both the loops. But here unfortunately there is a no two non-touching loops, so it is a nil, and three non-touching loops, and the remaining things are also nil. Okay, so we can go to the Mason's gain formula for calculating the transfer function. It is C of S is output and R of S is the input. So output by input equal to 1 by del summation of del k into pk. Here P1 into del 1, only one forward path, and we can remove the summations. Okay, so the del 1 value is 1 because no loops are not touching the first forward path. So in the first forward path, all the loops are touching. So there is a no loops which is not touching this first forward path. So only in this formula only 1 is present. So 1. That's all. So next del value 1 minus sum of individual loops. There is a no two non-touching loops, so it will be 0. Okay, and the remaining things also 0. So and we substituted the sum of individual loops from the individual loop diagrams. So 1 minus on first loop, second loop, third loop transfer functions are added up, and at last we will get the del value. Okay, so the del value is calculated, then again it is substituted in the Mason's gain formula. It is G1 Z. So while you substituting, you will get the pk into del k divided by del